Dear all, this is Dilip Udhani. In the last video, we have discussed ordinary point, singular point, RSP and ISP. In this video, I will make you understand how to find out the series solution of given differential equation near an ordinary point. I will make you understand this with the help of one example. Now, example 1 is we have to find out the series solution of the differential equation y dash minus 2xy equals to 0 about x0 equals to 0. So first of all, we have to show that this point x0 equals to 0 is an ordinary point. So for that purpose, we have to compare the given differential equation, that is y dash minus 2xy equals to 0, with the standard form. And the standard form of second order differential equation is y double dash plus p of x y dash plus q of x y equals to 0. So if you will compare y dash minus 2xy equals to 0 with y double dash plus p of x y dash plus q of x y equals to 0, we have p of x equals to 1 and q of x equals to minus 2x. Here you can see that both functions p of x and q of x are defined at x equals to 0. So x equals to 0 is an ordinary point. Now what we have to do, we have to find out the series solution of the given differential equation near an ordinary point x0 equals to 0. So for that purpose, we have to consider the series solution of the given differential equation about x0 equals to 0 be y equals to summation from n equals to 0 to infinite a n x minus x0 the whole raised to n. This is the required series solution. And in this solution, we have value of x0 equals to 0. This is an ordinary point. Now, if you will put down the value of x0 equals to 0 in this equation, it will become y equals to summation from n equals to 0 to infinite a n x raised to n. Now, this is the required series solution, so it will satisfy the given differential equation. So in the differential equation, in the given differential equation, we have term of y dash. It means we have to differentiate this equation with respect to x. So derivative of y with respect to x, it will become y dash, and derivative of x raised to n, it will become nx raised to n minus 1. Now what we have to do, we have to substitute y and y dash in the given equation, as this y, that is summation from n equals to 0 to infinite a n x raised to n, is the solution of given differential equation. So it satisfied the given differential equation. Now the given differential equation is y dash minus 2xy equals to 0. So put down the value of y dash and y in this equation. Y dash is summation from n equals to 0 to infinite a n and x raised to n minus 1 minus 2x as it is, and y is summation from n equals to 0 to infinite a n x raised to n. This term will remain as it is. Now we have to multiply x raised to n by x. Now if you will multiply x raised to n by x, it will become x raised to n plus. Now we have to find out the recurrence relation. To find recurrence relation, we have to make same powers of x. To make same powers of x, we have to convert each term of x into highest power of x or into lowest power of x. The choice is yours. Here we will convert each power of x into highest power of x. Here the highest power of x is x raised to n plus 1. You can see in the given differential equation, in equation 1, we have two terms of x. One is the power containing x raised to n minus 1 and the other is x raised to n plus 1. It means the highest power of x is, that is this one, x raised to n plus 1. Now we have to convert x raised to n minus 1 into x raised to n plus 1. To convert x raised to n minus 1 into x raised to n plus 1, we have to replace n by n plus 2 in a term containing x raised to n minus 1. If we will replace n by n plus 2 in the first term of equation 1, so what it will become? It will become like this. that is summation from n plus 2 equals to 0 to infinite an plus 2 n plus 2 x raised to n plus 2 minus 1 minus 2 times summation from n equals to 0 to infinite an x raised to n plus 1 equals to 0. Now plus 2 minus 1, the result is plus 1, so it will become x raised to n plus 1. So the overall term is summation from n equals to minus 2 to infinite an plus 2 n plus 2 x raised to n plus 1. Now minus 2 as it is, and this term is also as it is, that is summation from n equals to 0 to infinite an x raised to n plus 1 equals to 0. Now you can see that the powers of x are same. Here the power of x is n plus 1, here also the power of x is n plus 1, but the range of n is different. Here you can see that the range of n is from minus 2 to infinite, and here the range of n is from 0 to infinite. So what we have to do, we have to make same range of n. To make same range of n in this term, what we will do, we will put down the value of first n equals to minus 2, and then after the value of n equals to minus 1. If we will put down n equals to minus 2, then what will be its first term? Minus 2 plus 2. It will become 0. So first term will become 0 for n equals to minus 2. Now put down the value of n equals to minus 1 in this term. So it will become minus 1 plus 2. So the result is a1. So this is a1. And then after minus 1 plus 2, the result is 1. And minus 1 plus 1, the result is 0. So it will become x raised to 0. So this is the term for n equals to minus 2, and this is the term for n equals to minus 1. And the remaining terms are in the form of an plus 2, n plus 2, x raised to n plus 1, but it will start from n equals to 0 to infinite. So this whole term, this whole term will be 0 plus a1 plus summation from n equals to 0 to infinite an plus 2, n plus 2, x raised to n plus 1 minus 2 as it is, summation from n equals to 0 to infinite an x raised to n plus 1 as it is, and this is equals to 0. So this is first term 0, x raised to 0 is 1, so a1 into 1, the result is a1. And over here what we are doing, we are just take common x raised to n plus 1. If you will common x raised to n plus 1 from these two terms, the first term will be an plus 2, n plus 2, minus 2 as it is, and an as it is, that is equals to 0. Now what we have done, we have combined the terms of x raised to n plus 1 only, or you can say that we have taken common x raised to n plus 1 from these two terms, and the coefficient of x raised to n plus 1 become an plus 2, n plus 2 minus 2 times an, and that is equals to 0. Now what we have to do, we have to find out the values of the constant, that is a1, a2, a3, a4 and so on. So for that purpose, what we have to do, we have to compare the coefficient of x to 0, because in the right hand side we have been given 0 only, right? In the right hand side we have been given 0 only, so the coefficient of x square, x cube, x raised to n plus 1 all will be 0, and the constant term is again 0. So what we will do, we will compare the constant term to 0 and the coefficient of x raised to n plus 1 to 0. Over here we have constant term a1, and the coefficient of x raised to n plus 1 is an plus 2, n plus 2 minus 2 times an. So what we will do, we will equate to 0 the constant term and the coefficient of x raised to n plus 1, right? So we have written over here again, now comparing the constant term and the coefficient of x to 0. The constant term is a1. So a1 is 0 and the coefficient of x raised to n plus 1, that is an plus 2, n plus 2 minus 2 times an equals to 0. And this is for n greater than or equals to 0. This is for n greater than or equals to 0. So from here we will be having a recurrence relation, that is an plus 2 into bracket n plus 2 equals to 2 times an. So an plus 2 equals to 2 times an divided by n plus 2 for n greater than or equals to 0. Now with the help of this recurrence relation, that is an plus 2 equals to 2 times an over n plus 2 n greater than or equals to 0, we will find out the values of a2, a3, a4, a5 and a6 and so on. So to find out the value of a2, what we have to do, we have to put down the value of n equals to 0 over here. Now put the value of n equals to 0 over here, so it will become a2. So in the right hand side we have 2, the value of n is 0, so it will become a0 and divide by 0 plus 2, the result is 2. So 2 will cancel out, the result is a0. So indirectly the value of a2 is a0. Now put down the value of n equals to 1. If we will put down the value of n equals to 1, so it will become 1 plus 2, 3. So it is a3 and over here 1. So it will become 2 times a1 and divide by 1 plus 2, 3. So it will become 3. Now you can see that the value of a1 is 0. Value of a1 is 0. So put down the value of a1 is 0 over here, and 0 multiplied by any value, the result is 0. So the value of a3 is 0. Now put down the value of n equals to 2 in the recurrence relation, that is this one. So 2 plus 2, it will become 4. So value of a4, that is equals to 2 times the value of n is 2. So it will become 2a2 plus 2, 4. So the result is 4. And 2 by 4, the result is 1 by 2. So the value of a4 is a2 by 2. But you can see that the value of a2 is a0. So put down the value of a2 equals to a0 over here. Value of a4 become a4 equals to a0 by 2. Now again put down the value of n equals to 3. So if we'll put down the value of n equals to 3 over here, it will become 3 plus 2, 5. So in the left hand side we have a5 and in the right hand side 2 as it is. The value of n equals to 3. So put down the value of n equals to 3 over here. So it will become 2 times a3 and then after 3 plus 2, 5. But you can see that the value of a3 is 0, and if you put down the value of a3 equals to 0 over here, the value of a5 will become 0. So the value of a5 is 0. Now put n equals to 4 in the recurrence relation. So 4 plus 2 is 6. So it will become a6, 2 as it is, and the value of n equals to 4. So it will become a4 and divide by 4 plus 2, that is 6. So it will become a4 by 3. Now you can see that the value of a4 is a0 by 2. Replace a4 by a0 by 2. So it will become a0 by 6. So the value of a6 is a0 by 6. Now what we have to do, we have to put the values of these constant a2, a3, a4, a5 and a6 in the series solution, required series solution. And the required series solution is y summation from n equals to 0 to infinite an x raised to n. Expand this relation. So to expand this relation, what we have to do, first of all put down the value of n equals to 0. So it will become a0 x raised to 0 and x raised to 0 is 1. So the first term is a0. Now similarly put down the value of n equals to 1. So it will become a1 x raised to 1. Then after put down the value of n equals to 2. So it will become a2x square and finally a3x cube, a4x raised to 4, a5x raised to 5, a6x raised to 6 and so on. Now put down the values of a2, a3, a4, a5 and a6 in this solution. So a0 as it is, value of a1 is 0, x as it is, plus value of a2 is a0, x square as it is, value of a3 is 0, x cube as it is, value of a4 is a0 by 2, x raised to 4 as it is, value of a5 is 0, x raised to 5 as it is, value of a6 is a0 by 6 and x raised to 6 as it is. So a0 as it is, ignoring the terms containing 0 term, so we have y equals to a0 plus a0x square plus a0 by 2 x raised to 4 plus a0 by 6 x raised to 6. Now take a0 common, so we have y equals to a0 into bracket 1 plus x square plus x raised to 4 by 2 plus x raised to 6 by 6 plus dash dash dash, which is the required series solution for the given differential equation. Thank you for watching this video.